Hello, today we're going to talk about implicit differentiation. I know that when I normally take the derivative of a function, it's a function with y equals, and then something with x, so some function of x. But when I take an implicit derivative, I'm going to have a function with x's and y's together. So it's going to look something like, let's say, 5 equals 3x y squared plus 7y. So if I was to take the derivative of both sides of this equation, I know the derivative of 5 is 0 equals, and then now I have the derivative of 3x y squared. I know y is a function of x, so really this needs product rule because I have x times a function of x. So for my first step of the product rule, I'm going to take the derivative of x and leave y squared alone. So I'll have 3y squared, and then plus, now 3x stays here, and then taking the derivative of y squared needs the power rule, but it also needs chain rule, because I don't know what this function of x is up above in my first line. It could be something that needs a notable chain rule, or it could be something that its chain rule is going to be 1, but either way I have to account for it. So when we take the derivative of y squared, it's going to be 2y from the power rule, and then the derivative of y, which I'm going to mark with y prime. So now for the next one, when it's just 7y, similar to when it would be like 7x, I take the derivative and the x just goes away to 1. The same thing's going to happen with y, only I still have to account for chain rule with a y prime. So the derivative of 7y is going to be 7y prime. And now the goal is to simplify and get all the terms with a y prime by themselves. This term right here, 3y squared, doesn't have a y prime, so I want it to be on the other side of the equation. So we'll subtract it from both sides and get negative 3y squared equals, this will simplify to 6xy y prime plus 7y prime. And now that I have the y primes on one side and all the other terms on the other side, I'm going to factor out y prime. So we're going to have, this is going to be equal to 6xy plus 7 times y prime. And the goal of this is to get y prime by itself, since I want to know what my derivative is equal to. So I'm going to divide both sides by 6xy plus 7 in order to get y prime by itself. So doing that is going to get me negative 3y squared over 6xy plus 7, and that equals y prime.